3 million of medium and heavy trucks and 400,000 buses are produced every year. This is definitely a huge market. Do you know what Infineon's goals are in terms of commercial, construction and agriculture vehicles, that is CAV? Well, we want to drive the change of electrifying the drivetrain to reduce emissions and energy consumption. We also strive to foster autonomous driving with our sensors, microcontrollers and power ICs, offering high reliability in harsh environments. We also want to innovate onboard systems with our 24-volt compliant semiconductor solutions. By replacing mechanical solutions with electrical ones, we achieve higher comfort, safety and efficiency. Also very important for this market is the reduction of total cost of ownership. Every cent that can be saved due to a higher level of automation can be spent in implementing a more reliable system. The ultimate goal of all innovations for commercial vehicles is saving money. A truck is a logistic working equipment and is only useful for a fleet manager if it is running on the road. So the most important trend is everything that leads to an increased fuel efficiency. The electrification of the powertrain brings the implementation of start and stop technologies, like the ones used in the hybrid vehicles that entered the commercial vehicle market. Assistance systems, like the predictive powertrain control, help by telling you when to accelerate and brake in the sweet spot of a road profile. For example, when the truck is on a declining road, the system tells you to stop accelerating. Advanced driver assistance systems and the correlated increased need for safety are the second big megatrend. The automated emergency braking for trucks and buses, for example, is mandatory by law since 2016. Further improvements on reaction time and road detection will be implemented by an increased sensor accuracy. This sensor equipment and the semiconductor solutions will also help in making highway pilots and vehicle-to-vehicle communication more reliable. The remote control maneuver makes it possible that loading and unloading of the goods will be done automatically and the driver has additional rest time. It also increases safety as no humans are involved in this process anymore. Third big thing for trucks is the connectivity topic. Here we have the same thing we see for passenger cars, huge amounts of data that need to be processed and shared in real time. Precise geodata has to be collected and updated regularly. Road conditions and traffic have to be controlled. Forming a virtual road train, platooning, demands permanent exchange of data on speed, distance and acceleration between the trucks involved. Big data is the key word here. And what is the effect of these three megatrends on the electrical and electronic system of a truck? We need more powerful energy storage systems and powertrain redundancy. Sensor fusion and also system redundancy are necessary to bring higher autonomous driving assistance system levels on the street. Last but not least, the data management has to handle the data volume. Security, data integrity and high-speed data processing are key parameters. Fulfilling all these requirements at the same time is not a simple task, which is why the truck original equipment manufacturers face new challenges. The idea of electrifying CAV is not new though. History holds a lot of examples showing electrified agricultural vehicles. Early versions date back about 100 years, when electrical power was supplied by wire. Until recently, the Terex 3319 was the largest electric vehicle. Actually, it is a series hybrid with a diesel-powered generator and in-wheel motors. The drivetrain design for this kind of machinery is similar to a diesel-electric locomotive. But why now? Well, on one hand, because hazardous environmental conditions need to be changed. In fact, in some cities, diesel-powered vehicles are already banned. In 2019, the EU passed the first regulation to cut emissions for trucks by 15% in 2025 and 30% by 2030. These new regulations on emission control must be met or truck OEMs will pay huge fines. On the other hand, electric drives are far less complex than combustion engines. While electrification, reliability and availability increases, the cost per work and cost of ownership are reduced. Actually, about $1 per mile can be saved when combustion engine buses are replaced by electric ones. This translates into a saving of $600,000 during time of operation. There are so many important applications to turn a bus into an automated electrified bus. Taking a closer look at the electrification of commercial vehicles, many applications can be found, namely electric drivetrains, DC-DC converters, electric pumps and compressors, such as those used in heating, ventilation and air conditioning, as well as battery management and onboard chargers. The ecosystem around electric vehicles definitely offers many opportunities for Infineon to address, as electric vehicles rely on a sufficient charging infrastructure. Autonomous driving and hardware security, for instance, also require solutions that Infineon is actively approaching. As the block diagram reveals, hybrid drivetrains make use of a diesel-driven generator as a power source. This way, the diesel engine can be operated in a point of maximum efficiency most of the time, driving an electric generator. The propulsion itself is done by electric motors, controlled by power electronic converters. To provide electricity for a short distance, as well as peak power, a battery system that acts as a buffer and energy storage is necessary. In case the diesel generator combination is replaced by a hydrogen fuel cell, the system can be considered an electric-electric hybrid. The battery is mandatory to support peak power demands. A further DC-DC converter is needed to adapt the fuel cell's output to the battery voltage levels. Inverter and motor can remain the same as in a diesel-electric drivetrain. Within a battery electric vehicle, the battery alone takes the role of being the power source and features a larger capacity as in a hybrid design. Generator or fuel cells, along with the interfacing power electronics to the battery, are eliminated. No matter which approach in energy storage or generation is used, the electric mechanical parts of the drivetrain remain the same. For safe operation in all the available solutions, gate drivers, microcontrollers, and a variety of sensors are needed. This application diagram shows the electric drivetrain and the Infineon product families relevant for such application. In some cases, a fuel cell is integrated in addition to the battery to support during driving modus. In such a setup, an additional DC-DC converter is needed. CAV spans a variety of vehicles, ranging from last-mile delivery vehicles like rickshaws to the huge mining trucks with hundreds of tons of weight. Propelling these vehicles demands drivetrain power levels from a low kilowatt regime to the megawatt range. From discrete components to high-power modules, Infineon products are available to serve the whole range of power requirements. In this first module, you have seen what CAV is and why this market is a focus for Infineon, that the electrification of the CAV market is coming due to regulations and total cost of ownership, the list of key applications that can be seen in an e-bus, the different block diagrams for hybridization, the complete Infineon portfolio for the CAV market, and the key products for electrification. To make the most of this training, you should watch the other modules. In the second one, we will talk about the low voltage domain for CAV. Stay tuned.